In this lecture, we'll be learning about one specific class of ML models, what you call ensemble models or ensemble learning or meta learning. There are two popular examples of ensemble models available. One what we call bagging and the other one is boosting. Okay. So you might have heard about a random forest model. So random forest model is a popular example from the bagging category, and its objective is to reduce variance, and we'll explain how it does that. Okay. And the other category, what we call boosting, and some popular examples are ADA boost or XG boost, and it reduces the bias of your model. Okay. So in another video, we have learned about decision tree models, and it's a natural extension of a tree-based model that instead of having one tree for your prediction task, you use multiple trees. So multiple trees actually lead to a forest. So again, these are actually meta learn mechanism. So for the random forest model, our baseline models are our decision tree models. Okay. So instead of having one tree, you have multiple trees. Multiple trees lead to a forest. Okay. So let's say you have a data set. So you learn few trees, not just one tree. So tree 1, tree 2, tree 3. Okay. So given a data point, you pass through these three trees. So you will get one decision by this left tree, one decision by the middle tree, and then one decision by the right tree. Okay. And if it is a classification task, then you will take a majority vote as your final result. And if it is a regression task, you just take an average. Okay. So this is actually reducing your risk of making wrong prediction. So this is why we call the random forest model or the bagging model actually reduce the variance. Okay. So the underlying principle is that you use multiple tree to create a forest, and then you use decision by each tree and do kind of averaging as your final result. Okay. Now the second category, what we call boosting. The idea of boosting is you combine multiple weak models for your prediction task, and we will learn the concept through an example. Okay. So let's say you are given these red data points and then green data points, and you need to classify those. So you have a weak learner. Let's imagine this is a linear logistic regressor classifier that was able to classify all the green data points, but not all the red points. One of the red points become wrongly classified. Okay. But the thing is that you have your first model ready. Okay. And then you start learning a second model. Okay. And what you do in your second step, you actually put more weight on the data point that classifier 1 was not able to classify or wrongly classified. Okay. What will happen if you learn a second logistic regressor? You will find a model something like this. So here again, you are able to classify some red data point, but not all. But what happened? You actually use two learners. What will happen? You will have a strong classification model that is able to perfectly classify all the red data points. But the underlying principle is you are not relying on only one classifier. Okay. You are relying on two classifiers. So the idea of boosting is that you start with a weak one and then you try to stack more weak models. So you are actually boosting the performance of the strong model by just stacking some weak models. Okay. So this is the general idea of boosting, and we are using the boosting classifier in some of our notebooks. Mainly we are using the gradient boosting classifier from the scikit-learn implementation, but you will also find some other implementations, for example, the XG boost. But the whole idea is that these are examples of the boosting classifier. Okay. Feel free to ask if you have any question.